We'll be starting at 11:05 and we'll wait for 2-3 minutes for everyone to like sort of join in. Okay, solid. I think enough people have joined in on YouTube and Teams, and I would like to firstly welcome everyone who's present here. And if any of your friends haven't joined it, I would recommend you to sort of tell them to join in. And yeah, let's get started. Hi guys, my name is Mohammad Hisham Akhtar, and I will be taking a session today on Golang. Um, I'm a core member of DSC-VIT, and I welcome you all to the session here. So without any sort of further, all right. So yeah, so today's session is about Golang, right? So let's just talk about what we're going to do in the session first. So the first part of the session will be a bit about the session and I mean why we're doing the session, stuff like that. Then we will have a introduction to Golang where I'll teach you the basic core concepts of Golang. And then we will be making a small API with GoFiber and Garm. But so this is like the basic outline of the session. So now let's just get started with it. So what are the objectives of this session, right? So Golang, as you all might have already guessed it, it is a programming language. So the objective first is to gain a basic understanding of how to use Golang, right? Because every programming language has some sorts of uh, things that we need to generally know about the language, like how to use the language, how to loop in it, and stuff like that, the data types and all of that. So that'll be the first part of the session, and then we'll be getting a really brief idea on how to make a small REST API with Golang, right? So. Uh, So while we're talking about Golang and things like this, and them and but as you know that there are a lot of programming languages out there, right? And whenever there's some sort of a new programming language that is introduced to the general public like this, there has to be some sort of concrete way. I mean, the language needs to have something really concrete for people to deter them from the programming language that have been previously there, right? So why would say me as a developer shift from something like Java or Python to something like Golang, right? It has to address some sort of an issue or it has to have some sort of an advantage over everything else that is existing for other people to dive into this language. If a language is just like any other language, then not many people are going to use it, because of the fact that a lot of code bases already, really mature code bases already present in the previous languages. So what does Golang have? If we go and look at the history of programming languages in general, so when Java was introduced, Java had this advantage that it could run anywhere. It could run on a Linux written code could run on a Mac machine and things like that. But uh, but which wasn't the case with C or C++. You had to really compile the code in every different machine to run it. So why should we use Golang anyway? And you know, there are a few things that Golang offers us that sort of outperforms every other programming language out there. Of course, Golang has its disadvantages as well, but it has some sort of key selling points, right? So Golang was actually built back in 2009 by engineers at Google, and you know these engineers at Google, they were looking for a few things. So the first thing they were looking for was a language which was compiled, right? So it was like C or C++ or Rust, where the entire source code was taken and it was compiled into an executable, and that executable could be run. So that was the first requirement, and the second requirement was that the language was garbage collected. And when I mean garbage collected, that means that all of the memory allocations and deallocations that were happening would happen on their own, and you didn't really have to deallocate the memory on your own, which was not the case with C and C++. In that there are no garbage collectors. So and the application could be used for cloud native applications. So these were a few requirements, and they actually ended up coming. They actually, came up with Golang in there. So, and Golang really had its advantages, right? So Golang had all these features. It was compiled, it was garbage collected, and it was brilliant for cloud native applications. And over the years, Golang evolved, and there's a big ecosystem that's built around it, right? And today in 2021, Golang is one of the fastest growing languages there is, and according to some sort of surveys, Golang developers are the highest paid developers out there, some of the highest paid developers out there. So, I mean, Golang, in terms of job opportunities, does have a lot of it. And I've worked at a few startups here and there, and most of them either are already shifting to Golang or have already shifted to Golang. So, I mean, it is really being adopted these days. So because of its uh, not just because of its features like garbage collection and compiled, because that is already there, but also because of the fact that Golang has excellent concurrency handling, and it is one of the best out there, and it is a huge selling point for Golang. That is how Golang handles concurrency. So these are the few reasons why we should generally use Golang, right? So we already got out of the way like why we should use Golang, right? So now, uh, now what I do is that now we'll just have a sort of a basic demo, not just a basic. I'll just go into a bit of depth as well about uh, how we can use Golang in its sort of elementary operations, right? So at this point, I would like to share a repos link to you. I think Riddhi will put that link in the YouTube chats. I'll try to put that link in the Teams chat if that's possible. Yeah. So this is the repo link, and this will be shared to you guys properly. And so in here, I have actually compiled whatever we are going to do today. So these are the basics that we will be covering today: arrays, functions, if else, and everything. I'll obviously demonstrate everything out to you, and yeah, and you don't have to really copy everything that I'm doing. You can just pay attention to what I'm saying and try to understand the concepts, because all of the things that I'll be doing today, most of them are in here, so you can refer to them even after the session is over. All right. So now let's just get started. So you can go to golang.org here, right? And if you come to golang.org here, you can, you'll be able to simply download Go. It is a really, really simple download. You don't really have to do much about it. I mean, and you could come here and you could go to to.golang.org. And in here, I mean, the website for Go has a sort of a tour built in. And this is really a self-sufficient sort of tour in which uh, if you just go through this entire thing on your own, you will be able to, get a really good idea of Go. But then you don't have to really do this if you like watch my session. I'll try to cover most of the things in this tour, but there are a few things that will be left out, and I'll tell you what those are, and you can, go back and do those anyway. But yeah, so this is my terminal. Let me just make this bigger. Right. So this is the command line Go. It is a tool for managing the Go source code. And there are a lot of things you can do with Go. Like I could see my Go version, and my Go version is 1.16.6. I think 1.17 has been released, 1.17 rather. And but I have this installed, and we'll be using this itself for today at least. So yeah, and before I go and start writing code, I would like to show a few things. So one is Go path. Right. So these two are nothing but just environment variables which have been configured by this Go command line, and this is actually done for you by default. You don't really have to do this on your own. This is actually already done for you. I just want you to know the sort of significance that these two environment variables hold in general. So Go root basically means the path where your Go SDK is installed, right? So this is where the compiler and the native libraries and all are present in here. And Go path is actually your workspace, right? So we'll just cd into the Go path, right? And if I just do ls here, you can see there are three folders: bin, pkg, and src. Src stands for source code, pkg stands for package, and bin stands for binary. Bin means all the binaries that I compile come here. Pkg is all the the third-party libraries that I will use, and src is all of my source code. So if I go into src and come here and see that src has all these folders and things. I mean, it has an outline like this. I will come here, and then you can see here that I have three projects in here. And storing your projects in this way, like the way I have done, it is necessary. This part doesn't have to be the same, because this part is your Go path, but something like this has to be the way it I've shown here. And the reason for that, I will show it to you when we are building the REST API. Like explain to you why this should be like this, right? So now I have a folder here. I'll just create a folder here so that for our entire work today. So let's just call it 2cc session, right? It's created. Now we can go into it. And I'm going to be using an ID known as Goland. Goland is an ID by JetBrains, and it is a really, really good ID. I'd recommend all of you to use it. And assuming most of you are college students, you have a college email ID, and using that you can get this for free very easily. Just open Goland in here. And suppose you don't have a college student ID or whatever, and you want to use some other ID, Go works with almost everything else. It works with VS Code, Sublime, Atom, and I mean anything else you can probably think of. Golang supports that, so you don't have to worry about not using Golang or things like that, right? I mean anything you out there is probably compatible with Golang, right? So what we're going to do is we're going to create a file named main, and you can see as here the package is written something like this, but I'm going to change the package name back to main. And whenever I say package main, right, it means that this file is the file which I'm going to run. And if the package is not main, it means that it is a part of some other big project or something like that, right? So now this is our Go project, right? And there is one Go file in here, and the extension is .go, as you can see here. In C++, it is CPP, in C is .c. Similarly, in Golang, it is .go or .go. So whenever there's any programming language, and whenever we write a program, right? So there has to be some sort of an entry point to the program. So in C and C++, the entry point is actually int main, and then you write your program, right? If you have been using Java, it is public static void main, and then you have a string args and whatever, I mean, and then that is the entry point of your Java program, right? For Python or something like that, it starts right from the first. But in Go again, there is an entry point to the program, right? So we have func and we have main. This function is actually the entry point to your Go program, right? So whatever you do inside this function, I mean, whenever a Go file is run or this main.go is run, this function is where the execution will start, right? So inside here, we're going to do the first thing that, I mean, everyone does in their whenever they're learning a new programming language, and we'll just print something the world, right? And as you can see, this ID did an auto import for me. That was import fmt. Fmt is a package which is used to print stuff and things like that. It also has a few other usages. And just for your knowledge, what you can do is you can come here fmt golang, and you can come here, and there's a website called pkg.go.dev, and here you can see all the way to work with almost any of the standard libraries that Golang has, right? So in here, and I mean, I have auto imports enabled, so if I ever use a program sort of a library, this thing auto imports it for me. But if you don't have it, you can simply enable it in any of your ID. I'm pretty sure it's present in most of it, and if you still don't have it, then you can just import this on your own itself. I mean, it's not a big thing. So let's just go and run it. So there are two ways. I mean, I'll show you how to run it. So the way that, whenever I work with my ID, I can just run it like this by pressing the play sort of button. And you can see hello world is printed here. But many of you might not be using this ID. So what I'll do is I'll show you how to run it from the terminal as well. So go run main.go. That is how you run your Go program, right? Go run main.go. All right. And you can see hello world is printed here as well if we run it this way. Also, as I told you, this language is compiled, right? So you can, compile. So whenever I do this go run main.go, what this does behind the scenes is that it compiles the entire this Golang, this entire whatever we've written here, the source code, and then it creates an executable and runs it and then deletes it, right? So that is what this does for us. But we can also compile this on our own. So what we can do is we can write go build, and then we could write main.go, right? And if we come back here, you see we have a main.exe which is built for us, and this is nothing but the executable which was built out of this main.go. And then we could come here and run main.go here. .exe, and this thing will again be printed, which is hello world. So these are the various ways in which you can sort of run your Golang program, right? So now this is just basic printing. Now let's just start doing a few operations with Golang, right? So the first thing that you do with any programming language out there is that uh, declare variables, assign values to them, and things like that, right? So there are several ways in which you can declare variables in Golang. So the first way would be var a int, and you write a equals to say n, right? So this is one way for you to declare your variables in Golang. So first you put the keyword var, then you write the variable name. Of course, the variable name, all the sort of conventions that you have studied in school and I mean, if you haven't studied in school, I'm pretty sure you studied in college. Uh, all the variable naming conventions that apply, that the variable name cannot start with a letter, and there cannot be any special characters in it and things like that. So yeah, all the standard naming conventions apply, and then there's a type that you put in here, and there are a lot of types in Golang, and I'll show a few types to you here, but there's a huge number of types. So Golang data types, if you just come here, and if you can just see here, there's so many basic types in Golang, right? And you don't have to remember all of these or any of the complicated syntax that you see here. You don't have to really memorize any of those. You have my repo to refer, and you have so many other repos to refer. You can just Google it, and you can see it. You don't have to really memorize any of that, right? And as you can see here, it shows an error, right? It says unused variable. So this is a really cool feature in Golang, that if you have an import that is unused, or if you have a variable that is unused and you haven't used it anywhere in your code, you've just declared and let it be, Golang is actually not going to compile, and it is going to force you to either use it, or if it is an unused variable, you have to sort of delete that from your code. So that helps you maintain the I mean, it helps you make your code a lot cleaner, because you can't just have unused variables in there, right? So just to show you that this variable was declared, we just go and print this variable, and we run it. It prints 10, so which is of type int, right? Now what I'm going to do is that I'm going to introduce you to a different function for printing, and that is print, right? So in this print ln, we're just printing a, but in printf, what we can do is that we can format the variable. The variable a is, and we put a colon, and then we put a percentage, and we put a v, right? And we put a here. So what this will do is that it will take the value of a, and it will put it in here. So this is like printf in C if you've used it, and in Java it is equivalent to say system.out.printf. So something of that sort, right? Again, if we go ahead and run it, this will print the variable a is 10, right? And there's one more thing I'd like to show you. It's a these are really small things. We pass a variable, and but instead of a slash v, if we percentage, we do a percentage t, capital T, it is going to print the type of that variable, right? So if I come here, it says the variable a is 10 and its type is int. So I mean, you could just change the string anyway, and whatever you put in here, that is going to be simply printed here, right? And this is one other way you could generally print your variable, right? Now there's another way I mean, and instead of using int, if we could just use string here, and just put my name in here, Hisham, and I could sort of run it again, and you could see variable a equals to Hisham, and its type is string. And if you're using Golang, you don't have to really do and run your code all this time. You can use Control Shift F10, as it shows here, to run your code. Press Control Shift F10, and it will run my code this way. Again, you could just come here, you could do this, go run main.go, We'll do the same thing. All right. So this is one way of declaring the string, and I've already covered how to print, format and print and stuff like that. There's another really nice way in which you can work with variables, and that is, say the variable name is b. We could so here, so this is a variable b, right? And the value of this variable b is Sharanya. So if we put a semicolon, so if we put a colon before an equal to here, what this will do is that it will tell Go to to infer the type from whatever value we have given, right? So this value is actually a string. So what B will do is B will take in the value of a string. This is how, it'll infer what the value is and it'll put it for B, right? You don't have to specify the value, the data type explicitly. All right. So again, you can come here and we can print it. So we could go, you can see, A is, I haven't used A anywhere. So let's just use A as well, right? And both of these will work in the exact same way, right? I got to give a, yeah. So variable A is Hisham and its type is string, variable A is Sharanya and its type is string, right? If I took this away and if I made it 10 here, and if I ran it again, it would, infer the type on its own, like this. So earlier it was string and now it is int. All right, so this is basically about variables in Golang and a few data types. The types I've already shown you here. There's bool, there's string. Bool is for true, false. String is for string. There's different types of int. This is unsigned int. Then there's byte. Then there's runes, and these are basically aliases. And then there's float, and then there is complex. So, uh, these are pretty simple things. If we do 10.5 here, and if we run it, we will get that it is float 64, right? And a very cool thing that you could also do with Golang is that you could use complex numbers this way. And if I run it, you can see the value of this. Run it again. Yeah, the value of b is actually 10 plus 20i. So you can use complex numbers natively like this in Golang, which is really advantageous. And something I have not seen before in any other programming language. But yeah, so I may be wrong about not seeing it anywhere else. It might be there in others, but yeah, this is the first time I actually saw something like this, and I thought it was pretty cool to show. But these are all about variables, and Go have really sort of taken up too much time on this, so I won't really delay your anymore. So I'll just put a comment here and call this. Out comment for commenting this part out. All you have to do is control and the slash character, this character, and it'll comment totally by after selecting it. So now let's move on to say something like arrays, right? So one of the first things that you learn in any programming language is the way it deals with arrays or a list of elements, right? So even in Golang, it is nothing different that much. It's the same thing. So we could write array one. We could go up, we could redo a colon equal to, and then suppose the array is of type int, right? So we can do 10, 20, right? And then we do fmt dot fmt dot and array one that I can. Now if we run this, you get array one equals to 10, 20, 30, and the type is an array of integers, right? This could be, if we want to say, if we already know the number of elements here, so we could put in 3, right? And the type is this. Now suppose we do not know how many elements are going to be in there, we can just not put the number of elements, and this will take it, right? So yeah, and this can be an array of anything. This in here I've taken int. This could be an array of strings as well. So this could be an array of string as well, and the way you declare would be something like this. This would be say 4 strings in here, and we could do the same thing. We could print it, right? I would have to give right. So you could see this is the type is string here. So this is this the I mean this is just it about arrays. There's not much in here. One cool thing that you could do with arrays would be array slicing and indexing, which is, I mean, if you want to do an array indexing, array at 1 at 3. So, indexing in Golang starts from 0. So this would be 0th element, this would be the first element, this would be the second, third, fourth, fifth. 0, 1, 2, 3, 4, 5. So if you put array of 1 of 3 here, so it will be 0, 1, 2, and 3. So 40 should be printed, right? And we'll come ahead and see. Again, we have to give a escape sequence for it to go to the next line, and here we can see it's 40 printed here, right? Now the cool thing that we can do with Golang is string slicing. This is something that you must have seen in Python if you've done it before. So we could do 1:3. This is similar to substring in C and C++, and in Python it's just this sort of syntax 1, 2, 3, something like this. So what this will do is that it will take the first the elements at position 1 and position 2, right? And I mean it goes up to, if this is 3, then it will go up to 2. Then it is how it is there in substrings in Java as well. So I mean you could relate it there if you've done some Java, right? And you can see this, the first and the second element. The element is position 1 and position 2, 20 and 30. This is 1 and 2. If this was say 5, then it would take 2, 3, 4, 5. So 1, 2, 3, 4. Position 1, position 2, position 3, position 4. So I mean not a big thing. I mean this is basic array slicing, and I mean this is there in almost every programming language. You'll find some sort of basic array slicing present. So these were basic arrays, right? So we've done basic data types. We've done how to deal with arrays now. There's one other thing that I would like to show you, and that would be maps or dictionaries. And maps or dictionaries are pretty cool. In Python, you must have heard of dictionaries. If you've done JavaScript, you must have heard of JavaScript objects and things like that. In C and C++, not in C++, not in C, you have that STL map. In Java, you have collections. Similarly, in Golang, it is actually an inbuilt type for you. What you do is we could say map1, and so the way the syntax with Golang works is that we write map, that is a reserved keyword. Then we put a sort of uh, what you could say square brackets here. Then we put the type of the key and then the type of the value. Let's just call it age map, right? And then we can come here and we can map from string to int, right? So the one which is inside this square bracket, that is the data type of the key, and here this is the data type of the value, right? So let's just call Hisham, and since it is an age map, let's just say my age is 19. Just give it a few more elements. So Sharanya, her age is 19, and let's just make it Riddhi, and Riddhi's age is 21. And let's just make it one more, say Mayank, and Mayank age is 25. Sorry, Mayank. So now we can just come here and you can use the fmt dot print f, and the is equal to, and then we could go and just to print the type as well, just to show you what type Golang info it has. We'll print it, and then we'll do age map comma age map, right? And if we just compile and run this, you can see the age map is a map of this, and the type is of map from string to int, like we have declared here, right? And this is how Golang works with the data. If it is a map, this is how you can work with it, right? So map. Now, these are some of the few basic types. There's one more thing that we should cover, and that is structs, right? So if you have worked with C, you will know what struct is. Golang, if you, I mean, I don't know if you all have noticed yet, but the syntax of Golang is really, really similar to C, and uh, in some cases a bit similar to Java, but mostly it is very similar to C. So just like in C there's structs in C, in Golang also you have structs, and it is quite nice how structs work. Just give me a second, guys. Sorry. So yeah. So let's just create a struct. So let's just create a struct, say animal, right? Type animal struct. This is the way you would declare any struct out there. So first you write the keyword type, then you give it the name, and then you write the keyword struct, and then you open the curly braces, right? So let's just say name, string, and origin, it is of type string. Right, so this is your basic animal struct here. And I mean, I could come here and I could say this would be of an type animal, and say lion, and if, right, and then I could just put in here, I could put and if I run this again, the animal is lion Gujarat, and the type is main dot animal. So animal is actually the type of this. So this is structs, and even in structs, I mean, you could do some sort of a pseudo inheritance kind of thing. So suppose there's a type which you declare called bird here, and bird should have all the attributes of animal. So what you could do is you could say animal, and then the bird has something which is say specific only to the bird. So say we can put speed, and we could say and fly, which is a bull. What this will do is that this struct bird has these two attributes as well as some attributes on its own. So this is somewhat like an inheritance, not exactly inheritance if we go by the proper object-oriented guidelines, but this is a sort of an inheritance, or maybe you could call it composition. But yeah, so I mean, you could come here, you could say bird, bird one, and just call it bird, right? And you could just directly access values in here, bird.name. As you can see, bird.name is equal. And this is how you can, even if you were here, I mean, you could change this animal dot tiger, right? And we could animal dot origin, and we could, I mean, this thing also works, right? You could also do this. So bird one dot origin, and maybe origins of emos in Australia. I might be factually wrong, I'm not sure. Third one dot one and can fly. Emus can't fly. That is common knowledge, I hope. And then we could then print this the what is, and then we could if I run this again. Oops. Right. So the bird is, and we can come here, we can already see here that there is a bird struct sort of thing inside it. There's a thing for the animal, and then you have the other attributes. So it is obviously nested that way, but but the Go syntax allows you to, sort of modify this directly. So this is a pretty cool way you could, work with structs and things like this. And the purpose of this is exactly the purpose that you have learned in C to, sort of store a different store sort of a collection of data or something like that. In Java, you would do this with classes, but yeah, I would. And in Python, I mean, you can do anything with types, right? So there's no discussion of it there. But let's just call it struct, right? We will also comment this part out for now. And one from struct. So now we've learned all about types and arrays and maps and things like that. So now let's just jump into a few of the logical sort of operations that you can perform with Golang, right? So the first logical operation that you could possibly think of with Golang is if-else. If-else loops, these are basic things that all are always there in any programming language out there. So, so it is pretty simple in Golang. I mean, there's nothing very different in Golang if in terms of if-else and loops and things like that. So it is almost same as any other programming language. So we could say declare one variable. So let's say if one, and we could with the value 10 and call it if two and the value 20, right? And we could say if one is greater than if two, fmt.println else if one. Right? And here it gives me a warning saying that it is always false. I mean, that's obvious because of this, but we can ignore that warning for now because that is an IDE specific warning, right? And it says if one is less than if two, which is the case, it comes then it prints something in the else block. If this had been 40, and if we run, it would have printed the other one, right? So I mean, this is a pretty simple sort of way you can work with this, right? I mean, this is all there is to if and else in Go. There's one other sort of shorthand syntax that is there in Golang for any if. So I like to introduce two concepts here together. So it would be because they complement each other in general. So first concept would be how you could take inputs from the user in Golang console. So we could do fmt dot scanf, right? And I mean, as you can already see, I told you it is very similar to C, right? The language C. So what you could do is you could come here and we could say, and let's just say inp1, and this actually returns back an error which is unhandled error. So to do this, what we have to do is actually I'll write some code here and then I'll explain it to you. Right. So what I've actually done here is I've used the sort of shorthand syntax with if. So whenever we call a function like this fmt.scanf or something, it might return multiple things to us, right? And one of the things that it returns to us here is ERR, and it returns something else we've actually ignored that we don't need the other thing that it returns. But the thing that we have see the thing that we are worried about is ERR, right? So if we first take this thing, this is the thing that we would generally write. If we put an if before it, then we can sort of use this sort of syntax to take this in here, and then we could work with this directly right here. And I mean, this is a syntax that you would see commonly used when we are making backend. And when we go there, you'll understand why this might be a good idea to work with something like this. But yeah, this is one other syntax in which, I mean, there's nothing to understand here. This is the a syntax like this can be used in Golang and it exists. So I've just shown it to you, and maybe we could just and since that to show you the input thing also there, we could I could show you the input fmt dot println and printf right? And we could just run this, and we could input p343 and the type is int, right? This is how you can work with if else, right? Now, um, the last sort of thing that not the last, but we are kind of nearing towards the end of our introductory sort of session. So I just ask you guys once, if is there any doubts any of you have till now? Let me just open up the YouTube part as well, so I can see any of your doubts on there. If you guys do have any doubts, you can shoot your doubts right now. It'd be great. Thank you so much for all of you for sort of those fiery emojis. I hope you're liking it. If there's any doubts in the team section here, anyone, I'm encouraging you to ask any sort of doubts before I move on to loops and pointers and all of those. I would take that as a no. There's no doubts coming in. So I'll go and continue now. All right. So yeah, let's just continue. So the next thing that we would learn is loops, right? And I mean, loops is something that is very, very, very common in every single programming language you would find something like loops, and Golang is no different. And loops in here are also really, really similar to everything else out there. So we have for loops, and we also have while loops in Golang, but there's no other any syntax for while, but the syntax for just covers for that as well. And I'll show you how. So we could basically come here and we could create a small loop here, I equals to 0, I is less than equal to I plus plus, right? And then we could do fmt dot I comma a space, something like that, right? And we could run this and we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the loop, right? If this was 100 instead of 10, we could put 100 here and we could print 100 of them here, right? And if we wanted to print 1000, we'll do that. I mean, you could see it goes up to 10,000. I mean, this is how, I mean, that is the power of loops if you do not know that, with loops you can do one thing repetitively. This same thing could have also been done this way. So I could have taken I, right? And in here, what this would have been I less than equal. Right? I could have run this, and the same thing would have happened in any other language like C or Python or something of that sort. This would have been a while and not a for. But in Golang, there's nothing called while. The for loop does all of it for you, right? So this is how you would work with a loop and while in Golang. So let's just go back to the first way I showed you, right? So now this is one syntax for loops, and one of the few things that you must have learned in Python is when you were doing loops, which was different from C and C++, was that you could iterate through an array directly, right? And I mean, even in C and Java, you had those range-based for loops. But in Python, you could, at least the first time I saw, you could iterate through a loop directly. So even in Golang, you can sort of iterate through any array directly. So let's just declare, say, uh, L1. Let this be type. And if I wanted to iterate through this array, what I could possibly do in here is I could do the way we do it is k for k comma v colon equal to, then we write range here, array name. So what does k and v stand for? K stands for basically the position and v stands for the value. So that's what I could do, position, and would be right. And if you print it in here, you can see 1, 2, 3, 4, and this is 20, 30, 40, 50, right? So this is how you could iterate through an array in a for loop in Go. This is it. I mean, there's nothing else there is. This could be a sort of a infinite loop. Say we could go n equals to 35, and while for n is greater than 0, we could say fmt dot print is an infinite loop. And as you can see, my thing is my uh thing. I mean, my ID is already telling me that this is always true, and if we just put it in here, it just keeps on printing it, and it goes on and on. So yeah, there's infinite loops in Go as well. So yeah, that's cool. So these are loops in Golang. Pretty simple, almost the same as every other language. The concept is the same, but yeah, I think there are a few doubts on YouTube, right? Let me just open up YouTube and I'll answer your doubts. Does Go have a trigger function? Could you elaborate? I'm not uh, able to understand what your exact doubt is. What do you mean by trigger function? Something like JS. Can you elaborate a bit more on that? What you want to accomplish? Because I'm still not getting your exact doubt. Okay, on load. I mean that is not a function that is specific to JavaScript. That is whenever you are dealing with any user interface, and there is a sort of a framework that is behind. If you have even in that way I could say that Java or Kotlin also has trigger functions inbuilt in it when it's working with Aptiv, but that's not the case, right? So JavaScript was a language that was built for the browser, and that is why it appears to you that something like on load and on click and things like that is available in JavaScript by default, but it's not the case. That is because the fact that there's a DOM present and things like that. But whenever there are functions with, I mean, if you tried running on load in say Node.js, it wouldn't work, right? So with Golang, I mean, Golang is not a language that was built natively for the browser, and the code we're running is on our local machine and not on any browser and user interface for now. So that is why, of course, any of these functions like onload and onclick is not present. But had this been running in a browser, I'm pretty sure that people would have modified the API to, work with something like this. But yeah, I think there's no other doubts. We'll proceed with the last few things that is there. So the one thing that I would like to show you is pointers. This will be really brief with pointers. Pointers are very, very simple. It is this exact same thing. And the only thing with a pointer is that it basically is a variable that points to another variable, right? So we could say we could declare variable p1 10, and we could take a variable p2, and this would be the address of p1. Whenever we put and, it basically means the address of p1, and this variable p2 is nothing but a pointer, right? p2, and this is how you declare a pointer variable. So this is a pointer, right? And if we went ahead and printed fmt dot println print, right? So the variable p1 has the value 10 and int, and this is actually an address where this is being stored, and this star actually shows that this is actually a pointer variable, right? And if we just, instead of using p2 here, if we used star of p2 here, and if we run it, sorry, not this one, star of p2, and if we ran it, it would print 10 here. So if you want to print the variable which is at the location of the pointer, you could use a star here, right? And I mean, you'd ask me what is the point of this? The only reason is that if this p1 is instead of being an integer, if this was of the type say animal, right? And this had values, and this struct was say instead of having two values, it had like, say 50 values, and then passing this p1 around functions would be really sort of tedious, you can say. So that is why passing around pointers are a lot easier when work in any function. And with that we come to functions, right? What are functions? Functions are the same as every other programming language itself. There's basic functions. There's nothing much to functions in func, sum, say. This is how you would show the types in a function, and we could, if you have to return something in the function, you have to specify what you are returning, data type of what you're returning. This is how you would, sort of have the formal parameter of the function, and this is return a plus b, and you could just come in here. You could and you would get 50 here. So these are basic functions, and you know There's also a term known as methods. Methods are very similar to functions, but methods are actually defined on some sort of data type. So say that if I want to say put a method on type bird, right? So what I could do is that suppose I want to create a function known as print, which would print the details of a bird, right? So where is before the function name, I can put a b bird here, and inside this I could b dot name empty dot. Now I could declare a bird here. I would just take the bird from here itself, right? And instead of doing this, I could just do print bird one dot, right? So this function can be called in this way, bird one dot print. So this function is actually defined on this type struct bird. So this function would actually be called a method, right? Now if I just went ahead and ran this, you could see emo Australia 1 false. That is being printed whatever we've done in here, right? So there are methods in uh, Golang, and with this, I think we have come to the end of the basics of Golang. I mean, there's nothing much I can put in here. There are a few other things in Golang that I would recommend all of you to go and check out. One is switch case in Golang. I've not covered it. Then there is Go routines. There's Go channels. Then there is something known as interfaces. So these are the topics that I would cover. Uh, or you can find these very easily in a simple sort of uh, Google search. So anyway, I would basically take some doubts now on Teams and YouTube. Is there any doubts on Teams? Anything? This and YouTube. By the way, guys, can you hear my voice properly? Can anyone confirm that they can hear me properly on the Teams chat? Hello? Okay, fine, fine, fine. I think it must be some sort of any issue or something, right? And is there any doubts? Where is the team link? Actually, the Teams link is not available to everyone on YouTube because the team is for a few of the registered participants. But yeah, but the content is the exact same on YouTube and Teams. So, I mean, you can uh, ask me any questions on YouTube as well, and I would answer it. Do we have pointers to arrays? Yeah, why not? But whenever we have pointers to arrays, it's always a pointer to the first element of the array, and then you know we if you want the second element, it is basically pointed to the first element plus two because arrays are allocated. in a sort of a thing. I mean, contiguously. That is how memory it is handled memory. But I'm not sure if it is if Golang has some sort of different implementation behind it. But that's my common knowledge. So yeah, right. Okay. We'll move on now. And if there's any other doubts, we'll take it at the end. Right. Right. Now let's just have a small talk about GoFiber. And yeah. So GoFiber, you can come and you can go to um wait a, just a sec. So and you can come here, you can go to gofiber.io. If this website is blocked for you for some reason in India, a few people have this website blocked. Doesn't matter, you can come to the GitHub page of GoFiber and you could use it. And GoFiber, as you can see, it literally writes here, it is an Express inspired web framework built on top of fast HTTP for Go. And I mean, all that put aside, if you are a developer who's worked with Node.js earlier, GoFiber is something that is, inspired from this Express framework in Node.js. And it is, like, in my opinion, one of the best frameworks out there for Golang to build simple backend APIs with. And I mean, Fiber is really great because of the fact that it is very, very fast. And you can see here, I mean, it shows how fast it is. So you can check these sort of benchmarks out for your own. And the community around Fiber is great. Fiber has about 14,000 stars on GitHub and it is approaching 15,000. And there's always a healthy inflow of developers and stuff like that. So it is a pretty good framework for you to work with your Golang APIs and stuff like that. And I mean, it's really great. It has a lot of middlewares and a lot of third-party libraries which are built as plugins to it, and it has a growing community which is really promising. So, GoFiber is a basic web framework for Golang. You could use this to make your backend services, right? And we will be working with GoFiber in this session. And before I go ahead and start making the API with GoFiber, this website, this sort of repository, not website exactly, but yeah, so I have already pushed in the code here for for the stuff that we'll be doing today. And you can go ahead and you can check this thing out. And yeah, so let's just quit this and we'll now make a REST API with GoFiber, right? So I'll come here and in here, I'll delete all the things that I've done in here. So before I delete all of those, I'll just sort of run everything that I have showed you from the start so that you can uh, see once the stuff that we have done, right? And yeah, that- and this is everything that we did today, I guess. It's not a lot, but I hope it'll sort of help you, right? So you don't have to worry, all of these will be available in that repository I've sent to you. So yeah, Shamim Akhtar's why GoFiber, not other framework. It has only 14K versus Gin, which has 51K stars. Well, Fiber is a lot faster than Gin, and Fiber is built on fast HTTP. And of course, Gin is also a really, really good framework you could use. But for this session, we'll be focusing on Fiber itself because I believe Fiber is a framework that has grown a lot and has a good following. So we'll be using Fiber in today's session, I guess. Both frameworks have its advantages and disadvantages, but yeah. All right. So before we go and start using Fiber and things like that, what I will do here is that I'm going to sort of introduce Go modules to you, right? So suppose you have to use third-party libraries like GoFiber and a few other libraries out there. So what we would do is that you would have to enable Go modules. So to do that, all you have to do is you have to use Go mod init, and then you have to give a name for the Go module, right? So the name for the Go module, I'm going to use github.com/. This is the name of my Go module, and my uh this is why my this thing I put in a folder this way because of the name that I'm going to give to my Go module. And we would enable integration with my ID so that I can get a lot of those. And you can see a file named go.mod is created here, and the module is github.com md/2cc-session.go, and this is the Go version here 1.16. 1.17 is released, but I mean you might have that. I have something here. You might have a less smaller version as well, which is not a big issue, I guess. And yeah, so now let's just install our first library, GoFiber. To install any of the libraries, what you can basically do is you can go to their GitHub website, and you can come and go ahead and copy this. So it says go get with a -u and then the Go module for that. And I would let it copy, and here it is. And if I go back to go.mod, you can see here that these are added. These are all our dependencies that GoFiber needs. And this here is the GoFiber that we will be using, right? This is the library that we will make use of. So now, firstly, I would like to say that, if you guys are developers, you know what I'm talking about. And if you aren't, then let me just tell you that none of the developers out there, memorize the syntax of the code and anything of that sort. And most of them just, have an understanding of the basic concepts, and whatever the syntax is, they just, sort of Google it and use it on their own, right? So even today, I will be referring to this repository at times because, of course, I do not have any of a lot of the syntax memorized by heart, and it is absolutely okay if that's the case, right? So yeah, so now we'll just create a simple fiber app. So we will call it fiber dot new, right? As you can see, this has been sort of imported for me. And what we'll do is we will initialize a few middlewares. So, and you don't have to worry if these middlewares are, if you do not understand the meaning of these middleware. So cause is to make sure that I can call this API from the browser and it doesn't give me any cross origin resource sharing error. And I'll also use the middleware for logger here. So logger. And this is to make sure that all of the HTTP requests that are incoming is logged. Right. And then we need to run the server. So run the server, or that all that I'm going to do is I'm going to do log dot and app dot listen, and we will creating a fiber app. We are initializing some middlewares, and then we are running the server, right? And if I run this, just ignore that. Windows Defender thinks that my backend is a threat, which it is not. So yeah, and you can see this is fiber is running on port 3000, right? Now I'm going to create a folder called as API. Inside that folder, I'm going to create a directory known as endpoints. Inside endpoints, I'm going to create a file. And for now, what we are going to do is that we are going to create one route to check the health of our Golang application. Just make sure that our thing is running and we can access it. We'll create a function known as count routes would take in our app dot get that route here, say we'll create a function known as health check here, that this error does not occur anymore. And for any fiber handler like this, it has a few things in here, right? So the first thing you need to do is you need to take in a variable called C, which is the fiber context. And as you can already see here, I mean, I told you that whenever we are passing around things in sort of through functions, we use the pointer and not the actual thing, because as you can see, this fiber is a lot of things in here, right? This is a big struct. So if we don't pass around the entire thing, we can just pass around the pointers. Even with fiber app, I mean, you can see there's a lot of things in fiber app. So we can just pass around the pointer and it is just equivalent to passing around an integer. Always returns an error. And for now, what we'll do is that we will do c dot status. Inside the status, you put the status code. If you have used Express, you'll also know that this is something like res dot status. And status is the status code. You could put in a number here like 200, or you could use the fiber libraries built. Basically just maps to something like this. And I would recommend you to use this because this is actually sort of okay with the RFCs and everything. So this is there. And then we do a JSON. JSON, I mean, any data interchange and all with REST APIs happens in JSON. And dot map. And we can now we come here and this is app.get. This function mount routes has to be called in main. So and then now what we could do is we could run it and then you could see the status is okay. And I will not be using the browser for anything like this anymore. I'm going to use a tool known as Postman, which is I feel is the bread and butter of backend developers. And yeah, I can come here and I can and the status is okay, right? Now this port right now is 3000, but it could be something else as well. It could be 3001, and I could come here and should now be 3000. And if I worked at 3000, I mean, it would go on and it wouldn't happen. You can see the connection was refused because right now it is running on 3001, right? Anyway, I'll change this back to, but yeah. So our basic API is up and running now. Now what we have to do is we should connect our application to a basic database so that we can insert from the database, fetch from the database, and do other operations to it, right? So the database that I'm going to be using here is for today is Postgres, but Golang supports all other kinds of databases, so you don't have to, worry about it. I mean, any of the databases that you can possibly think of can be used with Golang. And the library that I'm going to use for databases today is known as the library I'm going to use to connect to it is known as Garm. So Garm is basically an ORM for Golang, and it is the most famous ORM for Golang there is right now. So this is Garm, and this is the source code for Garm. Garm has a pretty good website you can work with. So this is a Garm website. This is a sort of a application that I use to connect to my Postgres database. It is known as pgadmin. There's also other alternatives out there that you can use for pgadmin, which is dbbeaver and data grape and other like that. And you can use any you want to if you like. But yeah, so what we'll do is first we will install the Garm library, and if we come here, you can see Garm is already added for us. It Now we will create a new. In here we will create a new directory. Like this, we'll create a new file called. No, I'm not putting everything in one file because having this sort of file structure distribution is really useful in general. So yeah, I mean, and this database folder. I mean, what I'm going to just go. I'm going to go ahead and copy this thing from here, right? And I'm just going to go ahead and copy this thing from here. Here. And I'm going to explain to you what each of these lines mean. But before that, I was using a sort of a configuration management library in the repo, but I'm not going to be demonstrating the use of that here because I feel that is deviating a bit from the thing, but you can go ahead and check that out as well. Right. Now, basically, this is the Postgres URL. Any URL in Postgres is formatted this way. So it is first Postgres, then there's a password, which right now for my Postgres local server is password itself. This could be something different here. At the rate, you have the host name. For now, I'm going to use localhost, but say you're using an AWS RDS instance or Google SQL or something like that. Google Cloud SQL, this would be something different. And the port of Postgres is by default 5432, although you can change it while you are installing. So put the one that is concerned, and then you have the database name, which is Go Practice. That is the database that I have created here. And this already has a table here called post. I'm going to delete that table for now so that we can go afresh with it. So now it doesn't have any tables anymore. And then we just connect to it. This is a syntax for connecting to a database using Garm. You do garm.open. In that you do postgres.open URL, and then you pass in an empty config, and then you just return this. And this function getDB just is there to sort of get an instance of the database connection that I have made. Right. So now I'll come to main.go here, and right. Database.connectdb is not equal to in Golang, this is how we always handle errors. There's no try catch kind of thing in Golang. In Golang, you always see if the error is nil or not, and if the error is not nil, then you sort of give throw any error, something of that sort. Then you do log. And now the database connection is established. Now what we're going to do is we're going to auto migrate. And save. Right. After this we can put some print statement so we know. What migrations does is that we'll just come to migrations slightly a bit later, but yeah. So now what we've done is we've established our database connection. Let's just build it. So you can see it says connected to DB. So the database connection is done, right? But now we need to sort of create a table on the database and then work with that table on the database, right? So yeah, let's just go ahead and try to build the connection with the database, right? So to do that, we have to sort of, since Garm is an ORM, right? So the good part about ORMs is that they let you map normal objects in your programming language to a table in the SQL based database. So you can do that with Go as well. You can come here, and in here you can create a directory known as inside models. I'm going to first create a file called base, and this base is kind of simple. What I feel is that I'm just going to go ahead and copy this base from here. And this base is, and the way you define models in Golang for Garm is you just use structs, right? This is where structs generally shine. So you just use structs, and these three fields I feel are really sort of quintessential for any table out there. ID created at and updated at, it should be there in every table, and that is why I define this thing as base, right? And if you can already see here, this is something that is new I haven't told you about. So any sort of value in the struct can be given a tag this way. So if you can see ID as a tag for Gorm, and the tag is first of all the default value is a generated UID4 key, and then it is also the primary key. And if you see JSON here, JSON puts ID here. So what this basically signifies is that if you are working with a JSON for this, I mean, if you're converting this struct to a JSON, what this created at field would be in the JSON would be reflected as this. So this is the basic thing about JSON and structs and things like that. And then I'm going to create a model here known as post. Or I'll just call it posts for. So the only thing that we are going to be working with today, we are going to be working with a really simple sort of model, and that is type. There'll be only two fields in here. That will be title. Title will be of type string, and the JSON for it will be title. And I can have the title. And as I already showed you, you can sort of inherit or compose. So you put the base in here and the title description, and this is our basic model. And how this would be mapped to our database. The only thing that we have to come here and do is that inside this auto migrate, we put models.post, right? And we don't. the address and pointers always, and not the entire thing, because that is how convention is. And now, this is the purpose of auto migrate, right? So inside auto migrate, whatever model you put, what this will do is that it will read from the struct here, and it will take this and it will map it to your database. And I'll show you what that means, right? So we go ahead and run this, and it says connected to DB and migration's done. Now we come back here and we just refresh it. And we come here and we can see the columns that have been created: ID, created at, updated at, title, and description. Let's just sort of try fetching something from here. We can see it is empty, but we can see the fields that have been created in here. So the ID, created at, updated at, title, and description have been mapped from this struct in here to this database table. This is how you could work with it, right? Now, so I mean, this is the basic thing here. Let's just and better. Right. So now we come to endpoints, right? So for today, we're going to be keeping the endpoint really brief. We are going to insert into the database and we're going to fetch from the database. That's all we're going to do, right? So first we'll do add post, right? Again, the same thing, same drill, fiber.ctx, and then error, right? Now we will take in a post object from the body in here. So I've already, sort of created this Postman thing here, so you don't have to worry about it. So as you can see, this is post here. So we'll take in the title and the description of the post from the HTTP request, and we will sort of use that. To do that, what we have to do is that we have to use something known as body parser that comes inbuilt with a fiber. So what I'm going to do is I'm going to take a variable u. First, I'm going to initialize it to a new model post. And then what I'm going to do is that I'm going to use it to sort of, you could say in a way, take the input from this thing, and I'm going to try to insert it into this variable u, right? So that way, if the input is successful, I mean, if it is able to, sort of take the field from in here and put it into that struct, then we can say that, the input that the person put was okay. And if they weren't able to do it, then, I mean, the input was wrong. So we're going to use that shorthand if syntax that I showed you earlier. So if ERR equals to body parser that I showed you, and this is u here, r is not equal to nil. Now you can see that if this is successful, this thing is successful, then if this function is successful, then this u, then this variable u will have whatever is in here in the form of that struct. But if it is not successful, there will be an error, and we have to handle that error. So to do that, suppose this error is returned, so we'll do return c dot status. We'll do fiber dot status bad request, which has a status code of 400 dot json fiber dot here, put a key called as error and the value as true. The message as valid input. Right. Now we will take a instance of the database. Get the instance of the database, and now what we're going to do is we're going to insert. So to insert into the database is a really simple sort of task. So what we have to first do is that we have to take in db dot it, right? And we have to just pass in a sort of, you can say in a way, if we want to create a if you basically see this struct was mapped to this table, right? So if you want to insert something into this table, you have to pass a variable in this create, which is of type struct of that particular sort of variable. So we're putting in u here, right? So u is a type of type model.posts. So this u that goes in here, this has to be of type post for this thing to get put something inside this post table, right? This return an error. We take this. Then we can do something similar. And if things goes just fine, then we can just return something successful. So c dot status, and we'll do fiber dot status created. Status created has a status code of 201 dot fiber dot error here is or can be you can say the post. Let's just return the post details back, and this is you. So this should basically be it. We take in the value of u. We check if it can be parsed by the body parse or not. If it cannot, then the input is invalid. Then we initialize the database instance. Sort of, it's already initialized. We just sort of fetch it, and then we create it. And if there's an error in creation, we just send back that error. Otherwise, we just send them the post that has been created for them, right? We have to also mount this. So app.post. Now we can go ahead and we can run this. Migration's done, connected to DB. We come back here, post.create, and here I think it is, I've put posts here, so I just need to put an extra n. Suppose I don't send anything in here, right? And if I just try, it gives invalid input to me. So I know that that part of my code is working. Now I come back here and I post when this is a good post, right? So now if I send it back, it will create a post for me. And this is the post that has been created. This is the ID, the created and updated. You can see already that these two have been updated by Garm itself. These times are in UTC, so don't try to match it with the times right now. And yeah, so yeah, I mean, and you can see title description are the ones that we put in here. So this thing worked. The last thing that we will be doing today is how to fetch a post. Updation and deletion of a post is something that we will cover maybe sometime else, but this repo also has the code for updation and deletion as well. So you can go ahead and check that out. You can see update post and delete post is also here. So yeah, we'll be doing just the fetching because we are a bit short on time right now, and then we'll see where it goes. So func fetch post. Now we'll do the same thing here, but instead of taking the input from the body, what we're going to do is we're going to take the input from query parameters like this. You have a question mark, and then you have ID equals to, and then you have the value. So how do you fetch this, right? So this is really simple. Fiber provides a very nice way to do it. So you do c dot query, and in here you put the first key, which is the ID. This is the key, and the second thing that you need to pass here is the default value. So if it is not able to obtain anything from here, then it will make the value of this variable as the default value. And we can come here and the thing about invalid input, we can just copy this part. Right? Now, to fetch again, we need to get a database connection. Now, what we're going to do is we're going to be fetching by the ID, right? So firstly, what we'll do is we'll create a small sort of variable for post. So var post and models.post. Now to fetch, what we're going to do is we're going to do db.model. So first of all, we'll give it the model that it has to use. So it will be model.where. So this is basically similar to when if you've used SQL, there's a condition always at the end where something equals to something or where something like that. So this is something similar where ID equal to question mark. Here is the ID. So this ID will be put in here in the generated SQL query dot find, and find and put it into post, right? And this thing must return an error always. So we'll take copy, and then if all of this is successful, and error call message would be right. Post would be just the variable that we had initialized post. And then we have to obviously mount this. So app dot get just put the same thing here. Now we can build our code again. And we can come back here. This has to have an S here, right? We take this and we created a post. Now we'll fetch that same post. Sorry. So I made a small mistake in here. In the find post, I have to send the address and not the post itself. I think this will be, just compile it again. Right. And we can find the, the post is fetched. Now, one of the few errors that, I can sort of, I haven't handled yet is if the ID does not exist, then it just sends back empty, 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 which is not correct. So let's just handle that part once. So to do that, it's quite simple. So after the post is fetched, right, after you handle this error, we can just come here and see if post.id equal to, we can say the post was not found, and it's quite simple. Status dot error. And if we send here, this thing works, right? But if it is something, so it says post not found with the proper status code we get here. So this is basic. This is basically how you can, make a small, simple REST API. And of course, there's a lot of things that I haven't really, sort of followed in terms of making a REST API in here, all the best practices and stuff like that. But That was not the main sort of essence of the session. The essence was how to use Golang with it. A few of the things that you should definitely change here is to never work with raw. I mean, database strings are something which is like a sensitive data, right? It is the way you can connect your database. So this thing should never be in your code. This you should use environment variables or some sort of configuration file to work with this. So for that, there's a library called Viper, which you can use. It is really Viper, animal Viper, and yeah, so you can use Viper for sort of storing all this in a .env file or something of that sort. Then the structure of my code is also not very well structured. Inside this function add post, there's a lot that is going inside this one function itself. And by normal convention, you should break this up at least. So if you can see the kind of repo I've made here, I've broken them up into two parts. One is just this function add post, which deals only with sort of input output of this. It takes in and sends back whatever is needed. And then all the business logic that is there, it happens in this sort of controller in here, which does the connection to the database and things like that. There's a lot of things others you can do in here. You can go clean architecture, Golang. I have a repo on that as well, I think. Golang clean architecture. This is like a more structured way to sort of work with your databases and stuff and everything. There's a lot in here. So I mean, you can go. So this is known as design patterns. This is something that you should follow. Then there are a lot of other things as well, which it goes into making a backend. What I've tried doing here is tried showing you some simple ways to work with Golang itself. And if you haven't already noticed, then the time that is there is really less, 4 milliseconds and 28 milliseconds. These are really small times, and if you're working with Python or something, this would be considerably longer. So this is a very good advantage of Golang, that Golang is really fast in itself. And I guess with this, we are towards the end of our session. I will be taking doubts again on YouTube and on Teams. So if you can sort of explain to, if you have any doubts, then you can just go ahead and tell me, right? If there's any doubts, you can ask me, or else we can wind up the session. I'm waiting for any of the doubts. Anyone from Teams? No one from Teams has any doubt till now. That's 29 people in here. Pretty sure maybe one or two of you might be having doubts. If you have any doubts, you can just type it out in the chat, and I can answer it. I would take that as a no then. I guess no one has any doubts. So anyway, guys, thank you so much for attending. And you can go ahead and follow Google Developers Student Club on all our social media platforms. And it was pretty great to have you guys attending the session.